World. Welcome to the Scala and Functional Programming workshop. With ourselves, we have Lavínia, who is the organizer of Hackgirl, and she is also a researcher currently pursuing her master's. Welcome, Lavínia. Thank you very much for being here in this workshop. Over to you.
Hi, parent. Thanks for the invite. It's a pleasure to be here talking about Scala and functional programming, and you can share the slides as well. So, hi everyone. Today, again, we're gonna be talking about introduction to Scala and functional programming. And if you had any doubt, please share on the comments. I'll be seeing during the presentation. And this is an incremental presentation, so if you don't understand the concept well, it's important to let me know because we are going to be talking about the concept later. So, who am I? Paran did a quick introduction. My name is Lavínia. I'm from Universidade Federal de Pernambuco, here in Brazil. I'm a master student of computer science with my thesis gonna be about gender diversity in hackathons. I also have some papers on that, so you can check if you want. I'm a GitHub campus expert here in Brazil, and I'm also a part-time backend software engineer at Gympass, where was the company that made me have contact with Scala. And what is Scala actually? It was a language developed in 2001 by Martin Odesky in the École of Polytechnique Fédérale de Lausanne in France. Is actually a Java machine based. So it was a way to bring Scala some features like functional programming features and annotations that they didn't have at the time. Right now, they actually have some similar features, but in Scala is really affordable and companies can grow their code base. They have multiple um, fundamentals, like it's object oriented, that it's usually what we are taught in our university. So C++, Java, all the basic languages are object oriented and also has functional features. That is what I'm bringing into this talk. And is actually being used by companies like LinkedIn, Twitter, and Netflix. And in the advanced features, you can also use for big data. You can use to create servers, and it's really scalable. So, to run Scala in your machine, you should install the Scala. Here I put the link in the QR code to the documentation on Get Started, and also how to install the compiler, the SBT on the command line to compile all your programs. So, about functional programming. It's a programming paradigm that is based on lambda calculus, that is the smallest programming language that you have in history. It was actually made by the Alfonso, that was the oriental of Alan Turing, and is comparable to the version of software of what Alan Turing did on the hardware. And it focuses on what to solve instead of how to solve. Is what do you like to bring to the table, and not how I'll do that. And it has concepts like recursion, pure functions, referential transparency, first class, and high order functions. And it has both your advantages and disadvantages. Most of the advantage is related to scalability, and the disadvantages is sometimes can be boilerplate, and it has It has the difficulty to really master the concepts of the functional programming. Recursion, I'm assuming most of you know, that is when you call a function inside a function, but the other ones I'm going through that during the talk. The first one is a per function. That is a function that it has no side effects and depends only on the input variables, and it should always return a value. By definition, if the function receives the same input, it should return the same output because you don't have anything changing that concept. You don't have internet connection, for example, for APIs, and you also don't have any output like a print because this depends on the system and that is outside the function. So here we have an person that is actually using a variable that is not passed on the function. So if you sum anything that is outside, it's an per function. And if you are using that on the variables of the function, it's like initial value and you have initial value plus value. And this will bring every time the same output. The referential transparency is once a variable is defined, it does not change its values. So for those who are familiar with JavaScript, it could be a value, not a variable. And this avoids side effects of functions reassign the value. And is also good for debugging some functions that might have some problems because in this you have everything that you wanted real clear and it should be easier for you. For first class and high order functions, first class functions are treated as any other value by the language. So you can have functions being variables and it should have the same values as arrays, lists, or any type in in the language. And that is really necessary to create functions like map and filter that you pass a function for that. And having a function as arguments or a returning point for your program is the higher order functions definition. So for the example, you have salaries, so you have a sequence, and you have the function double salary that receives a int and then multiplies the function. And then you have this being a variable, so this is a first class, and then you're gonna pass this to a map, and this makes map a high order function because accept functions as arguments. I hope you understand that. And this is really a functional programming concept. So here's as an example of a tiramisu recipe that is a dessert that is really good as well. And here we have an example in the imperative programming or the way that we actually did. So when you see that, it's really difficult to know which part depends on the other because you have the dissolve using sugar 2 and the espresso, you have a mixture, and you don't know which part depends on the other, which is bad for making threads or make everything really scalable. And it's not clear if anything goes wrong in one of these steps, what you need to actually redo it and being able to not calling all the function again. So going by that, I don't know, for example, if I mess up to beat the cheese, I need to redo some other step, and I don't know which variables changed during the process. So, for example, if I beat the cheese, again in the next I have beat mixturing cheese. But if beat cheese fails, I so here are the same example in the functional way. Is the same amount of lines. So you have all the visibility that you need from the previous one, but you see that I'm assigning the variables for each step, and it's clear for me right now if I beat the cheese, the next one, the cheese mixture, it depends on the beat cheese. So if I pass only the cheese, it's gonna fail the recipe. And you can make all these different assumptions really easily by doing the functional way. And these have like a better explanation in the complete explanation in a blog post that I really indicate you to search after the talk. So, going by Scala, we have our railroad that is the object main stands up, and it simply prints the hello world that is the initial phrase that parent put in on this workshop. And our object here is a singleton, so is the starting point of any file. Is what I need to call so I'm able to execute the program. If I only have a class, the program will compile but it will not execute, it will not print anything. So going by data types in Scala, all values have types. So even null have a type, and it all derives from nothing. So why is important that is because you are able to have all your types safe. So you don't have like exceptions by null values during the program, and it's great for having concepts like extends that I'm going to mention later and pattern matching. So one special type here is the unit type that is equivalent to the void, but is programs that actually have exactly one output that is the empty one. For example, when you call a println, that function has the unity type return. So it does return nothing, but it makes some unpaired functions, so it shows the output. And spoiler, if you have a unity type, it's certain that the function is unpaired because you're making some changes on things outside the function. So by class in Scala is how you create the definition of an object that is our starting point, and it can have default values in the constructor. For example, here we have a point, and the point I want to always have the default value of 0 if you didn't pass anything. And you have some functions that is move, that is the movement when you receive two params, the dx and di. And you also have the override definition of toString, that is the print you want to be together with the parentheses. So the next definition that we have for Scala is the companion object that is actually declaring the same file and has the same name of a class. And just a moment. And With the companion objects, during the object type, you can declare the private members of the class, and you can create the apply method in the objects that allows you to create new instances without the new keyword. So when you call a person and the person has a companion object, you can create directly with the name and the age, and it's done. And you also have the unapply concept that it allows you to grab the name and the age without any problem, and you can have the change. So why this is important for Scala? This allows you to have case class that is has all the functionality of a class. The parameters are public and immutable by default, and the apply and unapply are generated automatically together with the toString method. So if I create a class person, name and age, I don't need to type everything on the same class, the object, the apply, because I already have on my case class. So this is great about boilerplates during the program. Again, why I need different case class is to have pattern matching. That is a really powerful tool in the Scala type. That when you have a bigger case class like person, you can extend that to have student and a teacher, for example, that is standard person. Stand is similar to um, the hierarchy that we have in Java when you have abstract class and you do the implementations, because of that has the hierarchy. And you can get a function called get message when you match not only the value of the student or the teacher, for example the name, you can match the class. So here, if I have a student, I can print the current grade. And if I have a teacher, I can print the current salary. And as you can see, the name of the variable could be different from the case class declaration, but of that, I'm receiving a person that is actually the bigger type. And the last one is the lower string that is actually it it didn't match the first one, it didn't match the second one, so I'm printing that it's not a valid person, although it could be anything. So this in production is used also to get exceptions. So if you have different exceptions, you can match what you need to do. For example, if I have an exception of user invalid, I can send a log to my backlog, but if it's a Java exception, I should probably only throw an error and get back. Following this type of matching, we actually have either that is similar to the option type in Kotlin that allows you to not having null in any point at our program. So we will have the right and the left, where the right is the correct value that you need and you want to continue on that. And the left could be anything, but usually is a string relating what happening, or is an exception, or how it's called in Scala is a trouble. Usually when you Usually it's used when you need to know the reason of failure. I don't see either in other cases, but here on the example we have the definition of eat ice cream. So if it's winter my season, I will put it's better not on the left. But if it's valid, I return a true. So when I gonna consume that, I'm gonna have either or the the wrong message. So that's really great to have all the exceptions there. So a more complicated feature in Scala that we have on functional programming is implicit parameters. So it's a param that it take the variable from the original context. So if I call a function, that variable is gonna search all the companion objects and the method calling to search for the implicit value. So how that means? I can have here a message called hello and the implicit value name world. So I have this display that receives a implicit value that is a string and is gonna print the message plus the string that you received as parameter. So if I put the println in the display, it's only gonna show the hello world because I'm passing no parameters there and they are searching for the ones that is on the same context. But if I put println display people, I will have hello people and not hello world because right now I have a value. So what is the problem with that? Sometimes it's not easy to find implicit parameter because they are searching for other companion objects, and if you have different classes, this is probably getting messy. So for newer version of Scala, that is Scala 3, the implicit has changed to be more explicit and actually having the message print on the console log, so it's easier to debug. But a more complicated example of how I can use implicit parameters is this one. So if I have in the easy way, that is the first thing that we have is an abstract class that is a monoid. A monoid should have an add function and a unity function that is a factor that doesn't do anything. So when I'm gonna implement the implicit test, I'm gonna have an implicit value that is what should I do if I receive a string as a monoid. So here I'm saying that I will need to create a new monoid that by definition a sum of two strings is gonna do a concatenation, and the unity is an empty string. The next function is if I have a int monoid. So if I receive an integer as a monoid, I should add the two values and the unit type it's a zero. So if I receive a sum when I have a list as parameter, I should implicitly call the monoid, and if the list that I receive is empty, I should return the unity type. And if I call the add, I should sum the rest of the tail. So when I call here, I have the sum of a list of integers. So by definition, you not passing the that this is an integer type. I'm gonna implicitly recall what is the definition by the monoid of an integer, and if I receive the list of A, B, C, I will implicitly call the string monoid. So the result you already know, the first one is 6 and the second one is ABC. So this was a really quick introduction, but how I can learn more about Scala? So Coursera has a course about introduction to Scala that is actually with the creator and is from the University of Lausanne. The Scala website has great resources about documentation, and we also have the O'Reilly book that shows a lot more details and some advanced features. And besides that, we also have some libraries like Akka that is a different way to communicate between programs that uses actors and messages and is more reactive than using REST programs. You have different applications, like I mentioned, big data with Spark and Scala, that is really used and is a language that is really flexible, and you should definitely try some new things on that. And thanks for the opportunity. Here are my social media, my LinkedIn, and my GitHub. So if you have any doubt, let me know. And that was I had to talk about today.
Thank you very much, Lavinia. It was a really lovely workshop. Enjoyed a lot. We got to learn about lots of things, and that is why we have lots of questions for you as well. And Scala looks very interesting to me, and I think the monoid example was really amazing. So we have a couple of questions for you. You mentioned that Scala runs on the Java virtual machine.
Yeah.
Since it runs on the Java virtual machine and Java code also gets compiled and runs onto the Java virtual machine, is it possible to use libraries made in Java inside Scala?
Yeah, some libraries actually work in Scala. It could have some problems with implicit conversions. Some of implicit conversions work in Scala. For example, the integer type in Java works in Scala pretty well because it has an implicit from the Java integer to the Scala one, but
Hmm.
some of the libraries should get messy. So it's probably better to work on native Scala libraries than use the Java ones.
Hmm. Makes
But
sense.
it should work.
Uh,
You need to test.
hmm. I'll definitely test that. That's the first thing I'm doing when I try Scala out. Okay, we had a React workshop a couple of days ago where Pritish was there and we talked about two kinds of components that we have in React. We have class components and functional components, and he mentioned that nobody uses class components anymore because we have functional components. We
Yeah.
also had a workshop by Adil, which was on AWS Lambda, and it seemed pretty convenient to simply write a code that gets deployed as a function on AWS Lambda. And most of the industry applications that are used by small businesses usually don't require too much of backend code, and it is usually easily to deploy that using a facility like Lambda. So, do you think that in the future, backend developers might have to be more focused towards using functional programming to develop backends in AWS Lambda and the like?
Yeah. So I think probably yes. I think the cases that we need to actually have classes are that when you have intrinsic types that needs to extend and need to have some more complicated types. But when you have like functions, everything is really simple, it's small, and as you mentioned, everything that we actually needed is very simple. The thing about lambda functions is it depends on the size that you have and the operations that you actually need to have. It could be expensive to have the backend on the lambda functions that we're actually writing a backend and deploy on the Kubernetes.
Hmm.
So it really depends. When it grows, you need to actually have a proper program with objects and reusability.
Hmm. Yes, I agree. And you already mentioned that Scala is a good language because it is scalable for Oh my god, Scalable and Scala,
Yeah.
the names. Okay, so we have so many kinds of developers. We have front end developers, back end developers, database engineers, and so many of them. Which ones do you think should consider learning Scala?
Yeah, I think Scala is really powerful for backend, and it actually has some libraries that allows you to connect to AWS and make some operations on that. So if you have, for example, a database on DynamoDB, you should be able to connect to Scala. And it also has different libraries, for example, Elasticsearch, that is used for indexing documents that you can connect to Scala. And for big data analysis, it's really a server-based language. So if you are a front
Mhm.
end, I'll probably go to React or go to JavaScript or other languages, because Scala is really focused on the server side.
Mm-hmm. Yes, I agree. Makes sense. Although we will wait for the day it comes to the front end. So currently we have two major versions of Scala in the market. We have Scala 2 and Scala 3. And as the documentation tells, Scala 3 is a complete overhaul of the Scala language, and there might be some instabilities. So how relevant do you think Scala 3 is in the industry? And do we need to learn Scala 2 as well?
Yeah. So this talk is on Scala 2. So that's a great question. Scala 3 was released last year. So it's a really recent build. But I did had opportunity to have a talk about Scala tree, and the part of the conversions are really great right now on the Scala tree, and was a complaint of most of Scala developers that if I have implicits a lot on during the program, I didn't know where exactly they did the conversion and what happened inside. So it became a black box. And
Mm-hmm.
being a black box to debug is really difficult, which Scala 3 solves. Most, but most of the features is that, like the case switch, the pattern matching, all the features. So I think it's great to learn the Scala tree, but you should be aware that most of the programs that you see examples and you see on the internet or the GitHub are on Scala too, because it's recent.
Mm-hmm. Okay, makes sense because Scala 3 is pretty recent, and overhaul makes us find it quite overwhelming. So I agree. I think it's pretty new, but as you mentioned, it will eventually take over because it is much better and more principled. Now we
Yeah,
have some trivia questions for you, really interesting ones. So there are so let's say there is a programmer who only knows about the functional approach of programming. Will that person be able to survive without object oriented programming? And I'm asking this because object oriented programmers can survive without functional approach. Is the opposite
yeah.
possible? It is.
Uh, by the functional programming definition, like you don't have even uh, println being a per function. So I
Mm-hmm.
would say
Totally
no.
agree. Mm-hmm.
But um, we need to have the functional concepts, because it makes our life easier when we are coding. Like I see the difference when I didn't know much about mapper filter that actually have monads and it's high order functions, and the different when I try to have like everything with a for.
Mm-hmm.
Like, and for is really imperative and object oriented, but when you have like the map and filter, it's clear to see what you are trying to do.
Hmm. Hmm. I agree with you.
But yeah,
And the
we can
next,
survive with the object oriented.
yeah, there goes functional programming. And people tend to start learning programming with. Usually, they start with an object-oriented programming language or a language like C, C++, Python. If a person's first ever programming language, so let's say someone is new to coding and the first language they learn is Scala, how would the other programming languages appear to them?
Actually, I don't think if the first language is Scala is going to be a problem because they have object-oriented functions. So we still have classes, we still have stands that is really about the hierarchy. So it actually has objects. But I think it should be easier to people to understand languages like Haskell, for example, because they know about the functional side and they also know about the object oriented side.
Mm-hmm.
So for them, like Scala being a first language, I hope it doesn't discourage them because, like I said on this talk, I didn't even pass about monads and some things that are more complicated about the functional ones because it's too much in just one talk.
Mm-hmm.
But you can be scared at the first sight.
Mm-hmm.
But
I
it
agree.
should be easier for them to migrate to either side, like going fully functional oriented programming or fully object oriented programming.
Mm-hmm. We need a mixture of the two.
Yeah, I think Python actually is also a mix of the two because Python also has map filters, and by nature you don't write code in Python with object oriented language.
Mm-hmm.
I
Except
think
the curly
Python,
braces, the rest of Scala looks like Python actually.
yeah, it also looks like Python as well.
Mm-hmm. And the last question that we have for you is nowhere related to Scala. The question is, why did you name it Hack Girl?
Actually, it was because of the other co-founder that is my friend Natalia, that she was a fan of Riot Girl movement. That is a
Mm-hmm.
punk feminist movement of the 90s.
Mm-hmm. Okay, now the title makes more sense. It's like in the American accent, we say girl instead of girl. That's why.
Yeah, but it started as a joke. It wasn't supposed to be the official name, but I like it so much. I say, hey, we should keep it as it is. I like it.
Well, really nice, really creative with the name, though. I think, I think we should take inspiration from this if we organize a hackathon specifically for girls in our country.
Yeah,
So thank you very much, Lavinia. It was a lovely workshop. So much we got to learn. I hope the students try Scala out on their own and develop applications and projects in Scala in future. I'll share the presentation. So please send me the presentation. I'll share it
sure.
with the attendees later on. And if they develop something using what they learned from you in today's workshop, I'll come straight to you and let you know. Thank you very much.
Please. I love to see.
It was really nice to have you at our community. Thank you very much. And I hope to see you again. This is definitely not the last time we're having you here. We'll probably have you at our community again. Thank you very much.
Thank you. Bye.
Bye.